Welcome to the session. I am Dr. S. Anusha Kathyayani, Assistant Professor in Department of Chemistry, Institute of Aeronautical Engineering. Today, we are going to see one of the laboratory experiment in engineering chemistry, which is the determination of chloride in water by using Argentometry. So, what is the aim of the experiment? Here, to estimate the chloride concentration in the given sample. So, it may be a drinking water or tap water. We are going to estimate the chloride concentration in the water sample. So, what are the apparatus required? So, one is the conical flask and another one is the burette with stand and the third one is the pipette and fourth is the measuring cylinders followed by volumetric flask and beakers, funnel and wash bottle. So, these are the apparatus required in order to carry out the determination of chloride content in water sample. So, the chemicals required for this determination are silver nitrate AgNO3 and potassium chromate K2CrO4 and distilled water and the sample water, which is raw water. So, what are the steps involved? The simple steps, first is sample preparation by adding the sample with indicator, then followed by titration with AgNO3, then calculation by finding V1 and V2. So, this is the simple step, the sample preparation, titration, then calculation. So, this way we can find out the chloride content in water. So, what is the principle involved in the determination of chloride in water? So, the amount of chloride in water can be simply determined by titrating. So, we are titrating this sample of water with AgNO3 with a titrant. So, here the titrant is silver nitrate solution. We are going to fill the burette with the silver nitrate solution and the indicator which we are using is potassium chromate K2CrO7. So, the reaction is a quantitative. Generally, there are two types of reaction, which is qualitative and quantitative. So, if it is a quantitative, we are going to determine the amount. If it is a qualitative, we are going to see whether it is present or not. Here, we are going to determine the amount. It is called quantitative. So, the amount of chloride present in the water, which can be calculated numerically. That type of reactions are called quantitative. So, the AgNO3 which is present in the burette reacts with the chloride ions present in the sample at 1:1 ratio and the results expressed in terms of ppm called parts per million or mg per liter. So, when silver nitrate ion solution is gradually added from the burette into the flask, the silver ions start reacting with the chloride ions. So, AgNO3 we took. So, it forms Ag plus NO3 2 minus ions. So, here when these Ag plus ions start reacting with Cl minus ions in the water. So, the reaction is Ag plus and Cl minus ions gives AgCl, which is a solid, which is a precipitate. So, these chloride ions form silver chloride, so means AgCl. So, the Ag silver ions and the chloride ions form AgCl complex, which is a white precipitate. So, it is precipitated at the bottom of the flask. So, the precipitation is in white color. If we can see the more chloride ions, so the chloride ion concentration increases, the white precipitate increases, means the more formation of silver chloride ions. So, here we can see from test tube 1 to test tube 5, we can see the increase in the intensity of the precipitate formation. This is due to the AgCl formation in the tubes. So, the end point of the titration takes place when all the chloride ions start reacting and precipitated. Here, we are adding the chromate as an indicator, which is yellow color solution. So, the chromate ions will react with the silver ions and results in the formation of silver chromate, which is a dark red color, brick red color precipitate. So, this is brownish red precipitate of silver chromate. So, this is the end point where this precipitate is formed. We are going to stop the reaction. So, the solubility product of silver chromate is exceeded in the presence of additional silver ions and then the precipitation start to process, means the precipitation occurs. So here the reaction is the two Ag plus ions reacts with the chromate ions, results in the formation of silver chromate, which is a brownish red precipitate, brick red precipitate. This is the theory involved. So coming to the procedure, first we have to take a sample of 10 to 20 ml in a conical flask. So the collected water sample into a conical flask, then add indicator, which is potassium indicator, 2 drops, which is potassium chromate. So the color of the water sample will turn into yellow. First water sample plus chromate solution gives the yellow pale solution. So then the water sample has to be titrated with the AgNO3 in the burette, which is 0.01. AgNO3 is filled in the burette. So the indicator plus sample gives this solution, and when it is titrated with AgNO3, it turns into a brick red precipitate because of the formation of here potassium, here the formation of brick red precipitate, which is silver chromate. Here potassium chromate releases chromate ions, and the silver present in the silver nitrate releases silver ions. The silver ions and the chromate ions react and forms a silver chromate. This is the end point. So this is the initial, this is the final. So before titration, after titration. So we have to tabulate all the readings from the experiment. We have to tabulate the readings. So while titrating from 0 to at which value the solution is turning into red. So at what ml it is turning into red, means it how much ml it consumed. So that has to be noted as V1 for distilled water and V2 for sample water. So the calculate chloride ion concentration from the above using formula, and the amount of chloride content is expressed in sums of mg per liter or ppm. So here in pictorial representation, here this is the sample and this is the indicator K2CrO7, and when the indicator is added, it gives yellow solution. Then it is titrated with, here it is filled with AgNO3, 0.01 AgNO3. So when the titration proceeds, here the yellow solution will turns into a brick red precipitate, which is called silver chromate. So this is the end point. So this is the process involved in this process of chloride content determination. So let's see the demo of the experiment in the laboratory. Welcome to the laboratory experiment on determination of chloride using Argentometry. Here we are going to use the titration method. Here the burette is filled with standard silver nitrate. So the silver nitrate solution was prepared from silver nitrate salt using distilled water. This is 0.01 normality silver nitrate solution, and potassium chromate is used as an indicator in this present experiment. We are going to titrate two samples, namely distilled water and the tap water or the sample water we are going to use in the titration. Let us start the titration. We are taking 10 ml of sample. So the 10 ml of sample was measured using the measuring cylinder. 10 ml of sample was taken in a conical flask. To this 2 ml of indicator was added. So now the color of the solution is pale yellow. Now we are going to titrate against this solution with 0.01 normality silver nitrate solution. So we have to titrate the solution until the color of the solution turns to brick red color. Once the color developed, we have to slow down the titration process and we have to take the reading in the burette. So the yellow color of the solution turned to brick red color, which is the formation of silver chromate, which is a brick red color precipitate is formed. This is the end point. we have to note down the reading of the burette. Now we are moving on to the next sample, which is sample water. 10 ml of sample was taken in a measuring cylinder. Two ml of indicator was added. Then it was titrated against the silver nitrate solution. So here also the end point is the brick red color precipitate formation is the end point. Once the color formed, we have to stop the titration and note down the reading. So the brick red color was formed here. So this is the end point of this solution. So from this we are calculating V1 and V2. So let's move on to the observation table and we will note down and we will calculate. So from the laboratory experiment, we can know the value of the distilled water and the sample water. So for the distilled water, the titration value first, the initial reading is 0 and then the final is 5. Here the volume of HgNO3 consumed is 5. Here the ml. Here this is the sample water. So again here 5. Here 20.5 means 15.5. This is ml. So here V2 minus V1 means 15.5 minus 5 equal to 10.5. We have to substitute this 10.5 in the formula. So 10.5 into 35.5 into 1000 divided by volume of sample we took is 10 ml into 0.01 normality of AgNO3. So this gives the result of X, means X ppm present in the water. This is the concentration of the chloride present in the water. So the amount of total chloride present in the water is mentioned as X mg per liter. So this is about the determination of chloride content in water using laboratory experiment by the method of Argentometry. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.